Let's talk about solving trigonometric equations. And solving trig equations initially isn't really all that different from solving any equation algebraically. That is to say, we want to use our standard algebraic practices, things like factoring or combining like terms, so that we can isolate the trigonometric function. And from there, that's where the trigonometry kicks in, trying to figure out what values of x satisfy that trigonometric equation. So let's go through and do a couple of examples of this. Okay, let's start with this first one. Let's find all the solutions of 2 cosine of x minus root 3 is equal to 0. So we're going to start by wanting to isolate that cosine of x. So that is to say, we're going to just use inverse operations to move that root 3 to the other side, divide both sides by 2, and then cosine of x is just simply root 3 over 2. Now from here, we want to figure out what are the values of x such that this equation is true. So we can think about maybe just even sketching out our angles. I know that at pi over 6, when x is equal to pi over 6, my x value is going to be root 3 over 2. So I can say pi over 6 is an angle that satisfies that equation. Well, what would be another angle? You might think, what about 11 pi over 6? Well, that angle would also satisfy the equation. That would also give me root 3 over 2 as our x value, and this would be negative 1/2, but we're concerned with our x. So these are two angles between 0 and 2 pi that satisfy this equation. Now, you might be wondering, well, wait, trigonometric functions are cyclical, so wouldn't there technically be more solutions than this? And the answer is, yeah, there are actually an infinite number of solutions because there are an infinite number of angles that could be coterminal with pi over 6 and 11 pi over 6. So how do we express all those solutions then? It wouldn't really make sense to write all of these angles out. Well, to find all the solutions, or what we call the general solutions, we would want a way of writing pi over 6 plus all of the other angles that end up in that same spot or are coterminal with pi over 6. So we would say x is equal to pi over 6 plus all of its coterminal angles n, where n is just some integer here. And we don't have to write that, we don't have to define n as being some integer, but we can say that pi over 6 plus 2 pi n. Well, what about 11 pi over 6? 11 pi over 6 also. I could just add or subtract 2 pi and get one of the coterminal angles that end up in this position right over here. So here are all my angles between 0 and 2 pi. And here are all of my here are my general solutions, or just what we would say all my solutions there. Okay? All right, let's try another one. So let's take a look at this particular problem here. 2 tangent squared x minus 1 is equal to tangent squared x. Now, if you're not ever sure where to start, you can always replace a trigonometric function with a variable. So for example, if I said something like 2a squared minus 1 is equal to a squared, well, if you've taken algebra, you would know to move a squared to the left side and find ways to use inverse operations to isolate a squared. So in the same way, I could subtract tangent squared x from both sides. And if I wanted to, I could move that 1 over to the right side. I could also leave it over there on the left side, but let me just simplify this to tangent squared x then is equal to 1. Well, I'm going to take the square root of both sides now to isolate tangent of x, being careful to know that this results in plus or minus 1. So then, from 0 to 2 pi, I would then want to find what are all of my angles such that I would get positive or negative 1. And again, I could kind of sketch this if I needed to. Just kind of fix that. So I could say, let me just do this in a different color. I have got pi over 4, 3 pi over 4, 5 pi over 4, and also 7 pi over 4. So let me write those out. We've got from 0 to 2 pi, our angles are pi over 4, plus 3 pi, or not plus 3 pi over 4, additionally 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so these are my angles from 0 to 2 pi that satisfy the equation. That is, when I plug them back into my original equation, I will get tangent squared x, or even into this equation, I would get positive or negative 1. Now, what about my general solutions here, or all my solutions? Now, I could take pi over 4 and add 2 pi n, 3 pi over 4 and add 2 pi n, and keep on adding 2 pi n to come up with all the coterminal angles. But in this course, we're going to be expected to write our solutions in the fewest number of equations possible. That is to say, look at our angles here. Is there any way that we can relate these angles with one another to express our general solution in the fewest number of equations possible? And if we look at these angle values carefully, we see that each angle is pi over 2 radians apart. So what we can say is that I can just take pi over 4 and add pi over 2, and that's going to take care of both this angle, and what do you know it? I can keep on adding pi over 2, so I can just express my general solution as pi over 4 plus pi over 2n. Okay? All right, let's try another one. Let's go ahead and do number 3, and there's a little bit, I want to actually change this up a little bit, not 3, actually we could have done 3, but you know what, let's just put 2 here. Go ahead and pause the video and see if you can solve this. One thing that you would not want to do is to actually divide both sides by sine of x. What we're doing here, if we do something like this, is we're actually eliminating one set of solutions in the same way that if we had x squared is equal to 2x, it would be ill-advised for us to go ahead and divide both sides by x. So we're not going to do that. Okay, so we're not going to do that. Instead, we're going to move all of our sine terms to one side. So sine squared x minus 2 sine x, and set that equal to 0. Now I can factor out a sine x, and I'm left with sine x minus 2 is equal to 0. From here, I can use the zero product property, and this is ultimately our goal as we're solving all of our equations, is we want to try to get this into the product of factors so we can apply the zero product property. Sine x is equal to 0. Sine x here, then, is equal to 2. From 0 to 2 pi, then, I could say my values, my angles that satisfy the equation sine x is equal to 0, x is equal to 0, and also pi. Well, what about when sine x is equal to 2? Well, think about this. This here is undefined. There are no angles that when I take the sine of that angle, I would ever get an output greater than 1. So this is undefined here. So we really just need to worry about 0 and pi. So what are my general solutions then? I would say that in general, my solutions are x is equal to 0 plus pi n, which I could just simplify really easily to just pi n. Okay, so we'll put that there. All right, and we're ready to go. Okay, oh, I should box this. All right, let's do one more. All right, 2 cosine squared x minus cosine x. This, I would then just solve like it's a polynomial function. I'm going to move that 1 over to this side, which allows me to then factor this. Oh, and that should be positive 1 there. There we go. Which then I can set each of my factors equal to 0. So I got negative 1/2. Cosine x is equal to 1. From 0 to 2 pi, then, my angles would be x is equal to 2 pi over 3 and 4 pi over 3. Let me actually just sketch those while I'm at it. So 2 pi over 3, and then also 4 pi over 3. All right, what about when cosine of x is equal to positive 1? Well, that would give me 0. That would be, let me actually just redraw these in a different color so we can see these, since it's going to lie on the positive x-axis. So those are my angles there, okay? So now I need to come up with general solutions. Well, how can I express these solutions, or all the solutions, in the fewest number of equations possible? Well, if you look carefully here, do we see the relationship between 2 pi over 3, 4 pi over 3, and 0? And yeah, all of these angles are 2 pi over 3 radians apart. So we can just simply say x is equal to 0 plus 2 pi over 3 n. And we can always just erase that 0 and just express this as 2 pi over 3 n. Okay? All right. Hopefully this helps, and in the next video, we will talk about how to solve trigonometric equations where there's more than one type of trig function within that equation.